Good evening, everybody. Good evening, and welcome to I don't know, we're on class number two of the Muon Beginners Muon Python course. I can't remember what the title of the course is, but learning some basic Python in order to collect data and analyze the data from your muon detector. I sorry about last week. A bit of a long story, but anyway, the fact is we're back on track today. But what I've done is that I know that there's been a lot of excitement on the groups about Dave Hardwick's work that he's prepared and done. Dave is a pretty experienced Python programmer, and data has been involved quite a lot in data processing as well. So he's put together a very nice Python package, which is a little bit more advanced than what we're doing on the course. But what I thought was we would try and look at some of the exact same methods that he's using, so that after you've sort of learned the basics, which is what I'm trying to cover here, it should form a good foundation for you when you start working with Dave's code. And in fact, there's a number of people already I know. In fact, I recognise one or two of you. I think David Roper, you've been using it, and it's nice code, nice and easy to understand. So hopefully, from what you learned today and next week, we should put you in reasonably good stead for starting to use that code. If indeed you want to join in with join the Hardwick Club, as it were, which it seems like quite a good idea to have, some common code that we can all use. Obviously, the methods that we're going to be looking at this evening, you can write your own code and go completely your own direction. I mean, obviously, this is that's the thing about Python, is that there are many ways of achieving the results. Now, what we're going to be looking at tonight are a couple of just a very quick recap, just in case we forgot from a couple of weeks ago where we ended up. So let me just go into the share, and I'll share my screen. So if I share that. Where we ended up the last course was that we learned how to do serial test. Here we go. So this is the code that we wrote in last week's. I keep saying last week's, don't I? It wasn't last week, but in the last in session number 1. So we learned how to import some libraries which are integral to Python on the Raspberry Pi, and from that we were able to read in from the actual muon detector and write the results to a file. Again, as I say, a very simple solution. Actually, funny enough, this command here was actually added as a result of somebody finding out that some of the characters weren't exactly UTF-8 compliant, and it threw an exception. I don't know, one or two people, I think, probably found the same problem. And my suggestion there is that there are some additional switches for the decode function, and if you look into the documentation for decode, you'll find that you can not only can you specify the actual format that you want to decode, but you can also specify a number of other things as well. One of which is that if you find a character that you can't decode, just ignore it, which is what we did, and it works out fine. It still writes the file. You just have this character which is not UTF-8, but it doesn't cause too much problems. So that's what the ignore is. So this generated a file on our Raspberry Pi. So what we're going to be doing today is taking that data from our file and learning how to bring that into another Python program, which we can then use to manipulate the data. So there are a number of things that we'll want to do with that data. We'll want to organize it in a way which we can use for analysis, which means maybe doing some filtering or some filtering of the data. We may want to find information out about that data. Filtering the data is one thing. The other thing that we want to be able to do is look at that data it may be in table form, and analyze that data. So look at things like maximum values, minimum values, mean values, median values, whatever. So do some statistical analysis on it. And lastly, once we've done all of that, we want to be able to display the information in some sort of chart or graph or some form of graphical representation in order to better see trends or patterns or in the data, because looking at lists of numbers is not always a very good way of spotting patterns and correlating different components within the data with one another. So charting that information. So that's really what we're going to be doing today. Now I'm going to use the same libraries in order to achieve all of those things as Dave is using in his Python programs. So that means that what we're going to learn this evening is going to be you can develop your skills with, and ultimately you'd be able to dive into Dave's code and work out how all that works. Now the two libraries that we're going. Right, the next thing is that everything we've done up until now has been on the Raspberry Pi. Now, the stuff that we're going to do this evening could be done on the Raspberry Pi. I'm actually going to do it on the PC simply because it's probably a better place to do it, because your PC is generally more faster and it's local and all the rest of it. So you don't need to do this on the Raspberry Pi, but you could do if you wanted to. The code that we're going to write tonight would run just the same on a Raspberry Pi as it would on the PC. Now, the two libraries that we're going to use this evening are, well, first of all, yes, the two libraries that we're going to use this evening. I'm going to switch to the web pages for those. So the first one is actually not that. I'm going to look at this one first, which is this library here is called Pandas. You can see here, as in the bear from China. Now, Pandas is where did I just come from? Because it sort of summarizes it with the FAQ. But Pandas, well, here we go. Here's the definition on the top line. It says it's a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool. So what it allows you to do is we're going to be able to read in our data from our file and create what's called a data frame. And we'll look at data frames in a minute. And these data frames are a sort of multi-dimensional blob of memory, if you like, which allows us then to do all the things that we talked about a minute ago with just trying to find that FAQ that I was looking at, because that was quite good because of the things oh, we go, yeah. So things like what kind of data can Pandas handle? Well, pretty much all data, which is a good thing. Can you read in tabular data? So data like the data that we've got, which is in a CSV format, where it's actually space delimited, which is not quite the same as it's not it's got a slightly unusual delimiter in the way that we stored the information, or what comes out of what comes out neat from the muon detector, I should say. Can you select subsets of that information? Well, yes, we're going to be able to do that. What can we do? Plotting? Can you calculate statistics? These are all things that Pandas is going to allow us to do. So this is, as I said, it's just an FAQ. So, but it goes through some of the main things that people are interested in. So you are going to have to install Pandas on your PC, which is pretty simple. If you've got pip, which if you haven't got pip on your PC, then I would strongly recommend that you install pip, because it's a very, very easy and efficient way of installing anything. But all you have to do is type pip install pandas at the command prompt, which can be the command prompt you can get to. The one that I would use is the one that's actually in hang on a minute, where are we going? Oops, yeah, this is where we're going to go. So in your terminal here on your PC. So I've opened this is a Visual Studio session that I've opened up, and I've opened it up on a folder which is on my PC. So unlike the last session where we were communicating to the Raspberry Pi, this is actually communicating with, this is actually on the PC. So I opened a folder, and if you want to open a folder to work on for this session, then you can create a new folder and open that on your PC and go in here. So from here, all you have to do is do pip install pandas, and it will go away and find pandas and install it on your PC. Now it's already on this one, but that's how long it takes to install pandas. So if you want to follow along, you can do that now, or do it later, or up to you whether you follow along. Now once we've got pandas, we can then analyze all of our data, and I'll give you a quick trip around the block of pandas. Now pandas is a really big and powerful library. It can do a hell of a lot, and we're only going to really just dip our toe in it, because any of you that watched my original Python series, we went into a reasonable amount of detail with pandas, so you can always watch that, and there are lots and lots of videos online about pandas. It's a very popular, well, it's pretty universal really in data analysis, the data analysis world. So in astronomy, all the data sciences, pandas is very, very heavily used. It actually works very, very well in conjunction with another product or another library, which is called matplotlib. Now matplotlib is very much like is an open source. Well, in fact, let me go to the matplotlib is a system for plotting data. It's an open source, freely available, multi-platform environment. So it's absolutely fantastic, and it works really well in conjunction with pandas. And you'll find lots of documentation where the two are working together. Now, what matplotlib is going to allow us to do, and this is what we're going to use once we've got our data in and we've done some manipulation, we're then going to pass the information into matplotlib in order to generate graphs. So like for instance, the plot, we're going to be using plot, but it can do bar graphs, scattergrams, a whole massive array of statistical. As you can see, these are there's pie charts, there's distribution charts, and then right through to much more complex plots, which I don't even know the names of some of these or what they actually really are, but you can go through and there are loads and loads of examples, and all of the 3D, 3-dimensional ones. So you can do like spectrographs and charts of that nature. And there are all of these are examples. So if you want to do a 3D scattergram, you can click on here, and it's got the code to do a 3D scattergram. Pretty much, it's a sort of code version of Excel on steroids, really, is the way I could probably describe it. But very, very easy to use in its basic form. So, and we're going to be using this plot function, and this is going to do some quite nice stuff for us. And it's very simple, few lines of code, and you get a lot of a big bang for the buck, as the Americans would say. So we may come back to this if anybody wants to look at some more sophisticated stuff. But lots and lots of documentation on matplotlib, as well as video tutorials on YouTube and etc. So with regards to installing that, it's pretty much the same deal. We go to your terminal and you would type pip install matplotlib, and as if by magic, it installs that as well. So we've now got all the bits that we need for doing tonight's work. So let's have a quick look at how those work in our program. So I've created a program called simpleplot.py. Now, simpleplot.py at the moment we're going to use this to use pandas to import the file, and then manipulate the data, and then lastly plot it out as a chart. So the simpleplot.py currently has no idea about pandas and matplotlib because they are external libraries. They're not part of Python. They're not built into Python. So some of the stuff that we did last week was built in, therefore we didn't have to do any importing. But we are going to have to import pandas and matplotlib. Now there's a couple of lines in here, as you can see. We've got import pandas is the first thing we're going to do. Now you could just import pandas without the as bit. And it just means that every time we want to invoke anything to do with pandas, we have to type the whole word pandas. It's fairly normal to abbreviate that to, and in fact, it's fairly normal to abbreviate it to PD. It just makes less typing when you come to invoke the functions or the methods belonging to the library. Matplotlib is a really big library, and it has an awful lot in it. The thing that we're most interested in is actually a sub set of libraries within Matplotlib, which is called pyplot. So we're not going to import the whole of Matplotlib because we just don't need the whole thing. What we're interested in is the pyplot. So I'm going to do matplotlib.pyplot. So .pyplot is basically, if you imagine matplotlib as being like a folder on a PC, then and underneath that folder there were a whole load of other folders. That's basically what that import would look like. So pyplot would be a folder within matplotlib, if you imagine it in a hierarchical structure like you would get on a PC. And again, rather than having to type pyplot in every time, I've abbreviated it to PLT, which invokes that library. So you can rename anything in Python using that as statement when you import an object, whether it's a whole library or just one particular class, you can rename it using the as. It's a very common technique. If I one nice thing that Visual Studio does for you is that if you highlight a line of code in Visual Studio, you can, if you right-hand mouse click on it, you can say run in the interactive window, and in fact, there's a shortcut which is Shift and Enter. If you can see that there. So if you highlight the code like we've got, you can either do the right-hand mouse click menu thing that I just did, or you can do Shift Enter. And if you do Shift Enter, what it'll do, he says confidently, which it's not doing right now. Hang on, let me just need to just yeah. If you highlight that piece of code and do Shift Enter, it will actually run it will open Python in the terminal. You can see it has, and it's imported pandas as PD. Now I know it's worked because it's come back with just the prompt, which means that it's done it, and it didn't return. If it returns nothing, it means it's done it. It's a sort of empty negative, if you like. I can do the same thing for import matplotlib. So if I highlight that and I do Shift and Enter, you'll see that it's typed it into the interactive window, and it's run that as well. Now, in order to verify that I've got those running, I can do a print statement. So if I do print pd.version, the dot under version, you'll occasionally hear me say the word dunder. It's a contraction of double underscore, which is typically used when you're describing any variable that has two underscores at the front of it, like that particular word, would be called dunder version. You'll hear it. You'll hear people say that in training videos and such like. So that's what dunder is. And the Americans love to use words like that, and unfortunately, I've fallen foul of it too. So, but if I highlight print pd dot dunder version and I hit Shift and Enter, so I'm doing Shift and Enter now, you'll see that it ran that piece of code in my interactive window, and it's produced 1, 2, 3, which is actually the version 1.2.3. That's just coincidental that it's 3 consecutive numbers. So I could actually at this point I can print. Oops, don't want to do that. I could actually do the same thing for if I do print and if I do plt dot version dot dunder version. That actually won't work because it doesn't. Well, maybe version's not in there, is it? That's because I haven't imported the whole library. That's the reason. This is just one component of it, and it doesn't have its own dedicated version. So that's actually not good. That's not a great thing to show you. But it works when you import a complete library like that. Generally speaking, there'll be a version on there. But it's just a way of showing you that we can activate the code. That was really my intention there, just to test code in the interactive window. What that means is that you can write your code line by line and test it, and if it all works, you can keep it in your program, and as you work your way through, you can you're building up an actual program. So I can actually now highlight the whole what I've done so far in my program. So I've now got these 3 lines of code in there, and if I do Shift Enter now, you'll see it'll do the whole lot, which it does all in one go. So you can test bit by bit your code as you go. So another nice feature of Visual Studio, which it has many. So what we've done there is we've imported the libraries that we're going to be using, and we've printed the version out. So far so good. Now the first thing we're going to do is we're going to want to open the file, the data file that we stored on our Raspberry Pi. Now what I actually did to get hold of that is that I went into, this is my Visual Studio code that that I was using in the last session, and this one's connected to my Raspberry Pi. So if I go in there and I type ls, I should see data.txt. So there's the actual file that I'm interested in. Now I've actually opened the whole directory, the whole Python directory. If you simply go to File and Open Folder, you can actually open the whole. This is the muon drive, and this is the home directory. So, which is where all of this is, and you can open the whole directory, which is just doing it again. But sorry, I should have. I don't know why I did it again because it was already open. But oh, I've got to enter the password. Cosmic. So yes, there was instruction to. I should have been reading it. So there's the muon drive. So this is the home directory. So if I go back, my serial test, which is the one we were just reading, that's actually now editing, obviously, on my Raspberry Pi. Now the data that we saved is here. So this is the data itself. Now I ran this afternoon, and I captured about 60 seconds worth of data. So I didn't run it for very long, but the point is that we need to walk before we run, obviously. So we've got about 60 seconds of data here. Now, one of the things that you'll notice is that there's no real description of what these columns are. There's a sort of description here, but it's all a bit lost in here, and I didn't want to sort of start hacking around in this line of code here. What I did is I looked at the way that Dave had done it in his, and so I suggest that we adopt a similar way of doing it for this evening. Now, in order to use this file on my PC, I could use it on the Raspberry Pi if I wanted to, but the easiest way, I think, is to just do a save as. So with this file open, what I did is I just went to save as, and I saved it to you can do show local, and you can go onto your local drive, and you can save it into the folder that we're working on this evening. So that's exactly what I did. So the one that I've got here, data.txt, is indeed, let me just move this down, data.txt is this file here. Now, what I've done, I've done this just to make life a little bit easier this evening for the purpose of learning what we're learning. But what I've done is that I've manually added a line of stuff in there at line 7, which are the titles of these columns of data. Now, so this is pretty similar to the way that Dave has done it on his version. So I didn't want to go into the way that he did that because it's a little bit more complicated than what we've learned already. But it's relatively easy to write a line of code like that into your file. I just wanted to sort of move forward onto the processing. So what I suggest we do is that we type that in manually. If you're following along, is that we just and I'll leave that on the screen so that you can all see it, and paste it into the first column of data. I did it. This line here has something to do with the time, I think, and the date of the Arduino that's inside the muon detector, and then the data starts flowing. So I just inserted it on that line there, just so that, because what we're going to do is we're going to import this data, and I'm just going to ignore these first 6 lines because at the moment we don't want to deal with those. So I just pasted that in to my file here, and then I saved it. In fact, I saved it in one called data1.txt. But that line 7 needs to say time item, time elapsed, I think that is. That's A to D value, so that's the raw 10-bit value. Then it's the silicon photon meter in millivolts, and then it's the time delta, so that's the time between each of the of the muon captures, and then there's a temperature on the end there. So that's what these columns are. So you need to use labels. I mean, they don't have to be exactly the same as mine, but you will need to make sure that you use the right labels when we come to write the code. Then they just need to match when we write the code. But those columns, each of those columns, that's basically the title of each of those columns. So it's fairly typical when you create a data set like this is to have the first row or a row somewhere in there which has all of the information about the values. Okay, so now that we've got this file called data1.txt, this is on my PC, of course, which means I can get at it from my program. So if we go back to my simple plot program. So the first thing we're going to do, I'm just going to move this up here so that we don't get all giddy about what's going to happen, is that we're going to create what's called a data frame. And again, typically when you're working with pandas, you call data frames DF and some usually DF something, so DF1, DF2, or something more descriptive. So it might be, this one might be DF muon data or something along those lines. I'm just going to call it DF, but you pick a name which generally speaking would have DF, which stands for data frame. So data frames are these multi-dimensional components which I referred to earlier. So in order to read using pandas, you can read a number of different file types, one of which is the CSV type, which is what we're interested in. The command itself is I mean, if you type in pd dot, you'll see all the different types of things that you can actually import. But the read CSV is the one that we're going to be using. So that's going to read our separated file, in our case, the separator is in fact a space. If you quickly go back and have a look at that, we know that all of the values are separated by spaces, and they have like a carriage return line feed on the end there. But those are all spaces, and each one's on a different row. So so we can say the separator. So the name of the file goes in there. The separator that we want, we can specify. If you don't specify it, I think it defaults to a comma. But you can specify the separator. It can be anything you like. It has to be a string, as it suggests there. And the other thing I'm going to do is I'm going to skip the first 6 rows, because the first 6 rows contain the header. And again, we're not interested in that for tonight. We're just going to be looking at the raw data. Clearly, the header file is important, and you will probably need to read it at some stage once we start developing these programs into, sort of into bigger programs. And in fact, Dave has dealt with those headers, and he's even got a JSON file for storing all the sort of locale data as well, which is a great idea. So there's lots of nice features in Dave's software, which we can, well, hopefully over the coming weeks, and depending on how long this goes on for, we can dive into all of those different things as well. So that one line of code is very powerful. It's going to open the file, it's going to read the data in, and it's going to create this data frame which has all this information in it. Now, again, if I just highlight that one line of code and I do Shift Enter, it will run that piece of code, and it's basically executed it, and it's come, but we don't see anything in here. But what we can do is we can now start looking at this data frame. We can analyze the data that's in there. So let's just wind this down slightly, and we'll start off with some of the basics here. So if you want to look at the data frame itself, a simple way of doing it is to do .head, and what .head does is it prints the top 10 entries or the first 10 entries of any data frame. So if I do Shift Enter on there, there you go. So you can see how that our line that we inserted with the names of the columns, it understands what that means. It knows that that is the names of the columns, and it's also got all our column data in there in place, and it's even inserted item numbers in the very first column as well. So there's all sorts of additional benefits that you get at that point. If you're working in something like Jupyter Notebooks, these printouts are also really nicely formatted, so it looks like it's published data in a book when you do it in a Jupyter Notebook. We'll be looking at Jupyter Notebooks, I think, hopefully toward the end of this. Not today, but maybe next week we'll look at Jupyter Notebooks, because it's a great way of providing documentation for these sorts of things. Now it does I think it does. It must do 5 rows actually. Does head, but you can specify how many you want to look at. So you can go into head and you can say if you want 10, you can put 10 in there, and then if I run that, you'll see it does 10. There you go. So you can look at however many rows you want, and in fact there are all sorts of switches that you can put on head. So you can put return the first n rows, but you can also do rows. There's all sorts of other values you can put in there. Yeah, the default's 5, and you can also do you can actually start specifying all sorts of other things. It says there's loads more to the head command than just that, but it's a very good way of just quickly looking at your data to making sure that it's come in the right sort of way. There are then a whole number of other commands that we can type. So, for instance, if you want to find out what all the columns are, what all your data values are, one way of doing it is using the as a columns method. So if I do columns, you'll see that see down here, it just gives me a list which has all of the actual columns in there, and this is the data type of the what it's returned. But so that's great if you want to, especially if you've got a lot of columns, that can be very handy. It allows you to find the column that you're looking for, or work your way through all the columns one by one. If you want to look at one particular column of data, you can actually specify that like you would say in a list or a dictionary by using the square bracket. So the DF is our data frame, and if I put square brackets after it, I can put indexes in there or names in there depending on which component of the data that I want to look at. So if I just wanted to look at all the temperatures, which is that very last column you can see there, I would just do print temp. So let's have a look at what happens if I do that. So if I do shift, so there you can see we'll just get all of our temperatures. Now what it does when there are a lot of values is you can see what it's done there is it prints the first 5 and the last 5, and it shows you that there's a whole bunch in between. So that's quite nice. It shows you that you've got all the data that you're interested in, what those what it looks like at the beginning and what it looks like at the end. And again, you can customize that with additional commands to give you, if you wanted to see all of the temperatures which were greater than 22 degrees or complied with some type of a value, it would automatically sort those all out for you. If you wanted all those temperatures to be offset or wanted them in Fahrenheit or Kelvin, you could put a conversion in there and it would do it on the whole data frame. So you don't have to work your way through each individual value. You can just say, put a Fahrenheit to centigrade conversion in and say, do that to the whole data frame, and it will do the whole lot in one go. So that's where Pandas really starts to come into its own. So for instance, if I wanted to work out, I wanted to see the mean temperature in all of my data, I would now what I've done here is this is just a simple print statement. So I'm printing the word mean, and then the print statement, you can have multiple elements within the print statement. Now, this isn't a great way of doing it, but it's a way of doing it. And then I've said I want you to show me all the temperatures, but instead of just showing me all of them, I want you to work out what the mean is and just give me that value. So that, if I do that, you'll see that it says mean equals, and you get 23.12343065. Yeah, that I don't think the temperature sensor in the muon detector is that accurate, unfortunately. But that's it's done it to however many decimal places it thinks we want it to. Now, if you get numbers like that, then an easy way of getting rid of all of that, all of the decimal places, I would suggest that well, you can use there are rounding functions within in the maths in the maths elements, but if you're printing things out like this, what I would suggest you do is use the format command or F strings, depending on what version of Python you're using. But F strings work similarly to this. So what am I talking about? Well, there's a string here. If you look at the two single quotes there, between those two single quotes, we have got a string, and the string has MEAN equals, and then it has a pair of braces. Now those braces signify a place where I want data to go. So if I actually just take those out, that's out for the moment. So that's my my string, the actual string of information that I want to print. Now, rather than printing these parentheses, what this is a placeholder. So if I do .format, or rather format, is a method that belongs to all strings. But what it does is that it allows me to pass values. So here is what I had in the example above. So that is the mean value of all my temperatures in my data frame, and it's going to pass that value. This is a value that I'm basically passing into the format method, and format will insert that into here. Now, if I leave it in that form, rather than let me just run that. So if I run that, you'll see we get exactly the same result as we had before. So we get all those decimal places. Now, the nice thing about format is it has other formatting you can put in there. So if I put colon dot to F, and the F stands for floating point, what that means is that after the decimal point, I want just two places of accuracy as a floating point. So that notation there works for any number, any floating point number. So if I were to print that out now, what you'll get is 23.13, which is obviously a lot nicer. So the format command is definitely worth learning when you're manipulating values. You know, if you don't want to get 12 decimal precision, which is crazy. So
can I just ask a question, Roo?
Yeah, absolutely.
Does that format command simply lop off all the trailing decimal points, or does it do the rounding?
No, that particular one is just lops them off.
Lops them off. Okay, thank you.
But there is a round function which you can use as well, which does obviously exactly what you say. So yeah, I don't know what is that value, 133. So in fact, it's correct for here. But if it was 137, it would still say 13. Yeah, it's not actually rounding it; it's just lopping them off. Yeah. That's what I was saying, is that it's okay for sort of just quick printing things out if you want to, but if you were wanting to be particularly scientific about it, obviously that wouldn't be acceptable. Okay, so these data frames, you can not only control single items but the whole data frame as a whole, like I've been explaining, you can also operate things like mean, and you'll find if you do df and then a dot, you'll see that there's things like there's max, there's min, there's median, there's mean. So all of those mathematical, statistical functions are all built into the data frame itself. So that could apply to just one column, or it could apply to, I've got Copilot switched on at the moment. Let me just go and switch it off. Oh, you just have to ignore it. I've got Copilot on, so that's what keeps popping up in grey. So yes, if you experiment with these data frames, you can start to see how you can get analysis data out of the objects doing it in this way. Now, what time are we on? We've got 15 minutes left, so let's concentrate now on a few. So let's just look at the data, some data that we're going to work on. So we've got two columns. We've got time elapsed, and we've got the millivolt column. The millivolt column is obviously for the is the actual samples themselves from the scintillator, and the time elapsed is just is milliseconds, which comes out of the Arduino. Now, there's been a lot of discussion about the way that these timestamps are working, and I'll talk a little bit more about those in a minute when we see this working, and we'll go have a very quick look at Dave's work on that, because I think the data that we're capturing in our example may not be as useful as the way that Dave is now doing it, but we're not here to sort of anyway. So if I do this line of code now, what this is going to do is print out the two columns, just to show you that that's the data that we're interested in. So if I run that, you'll see that we've got our elapsed time, which starts at 368 milliseconds and goes all the way through to 60,659, and then we've got the actual values of the scintillator in millivolts in the second column. So if you want to type, as you can see there, you can print any of the columns by putting them in a list like I've got there, and you can change the values of the things. So if you wanted this in seconds, you could put divide. You could well, we're going to do that in a minute. Let's come down here. So what I'm actually going to do now is set it up for, I'm going to create a plot, an XY graph, which is going to have, along the Y-axis, we're going to have the actual, or the Y-axis will be the magnitude of the scintillator, and the X-axis will be the elapsed time. So very simple to do that. So we're going to say Y equals the data frame MV, so that's all of my values for the scintillator. The X axis is going to be made up of the data frame time elapsed, but I'm going to divide that by 1,000 because they're in milliseconds. They're in milliseconds, so we want that into seconds because it's just going to look neater on the graph. So this is another example of, you can just do a piece of maths like that, and that will do it on every single value in the data frame. So much easier than working with a Python list or dictionary where you'd have to do that manually for all of the fields. Pandas does that just for you in its stride. So we've got the X and the Y. So what we need to do now is plot that. Now we're going to use matplotlib to do that. So if you remember, I renamed matplotlib to be plt, or PLT. And the plt will allow us to do histograms, In fact, if I do PLT, you'll see if I do a dot, you can do histograms, I can do scattergrams, can do pie charts, you name it, they're all in there. So the one that we're going to do is plot, which is just an ordinary line graph. So we've created our X, we've created our Y, and this is our plot. Now, if I run that, it won't actually display anything. So I'm just going to run it now just to show you. And it will, what it does is that plot, or PLT plot, what it does is it returns a plot object. And you can see it there, in fact. It says it's a matplotlib.lines 2D object with a memory location. That's not much good to us. What we want to do is see it on the screen. So what we need to do is do a plot show command, which is here. But before we do that, I'm just going to make it a little bit nicer, and I'm going to do some labeling. So plt.x label allows us to put a label along the x-axis. So I've put elapsed time in seconds as the label. I'm going to do the y label is going to say what does it stand for? SIPM. It's silicon something. Was it?
Photomultiplier.
Photomultiplier. That's it. Silicon photomultiplier. Go. I was reading about it last week when I was preparing for the course, and I thought I must remember that it's a silicon photomultiplier because it makes me sound like an idiot when I'm doing this, and I don't even know what the thing is. But I'm going to learn about muons. Honestly, I will get there. I've got the detector here. It's detecting muons. I want to know more about them, but these things, right. So that's my Y label. So I'm also going to put a title on the plot, and I also fancy having a grid so that we can see the values against the grid. So there's all sorts of tweaks you can put in there to label them up, and then you need to do this show command. And once you've got all of that in fact, we can run all that now. So we've got we've already run that, but we can run that again. We can do plot xy and the plot show. So if I run that now, we should get a graph, and there we have. Now, this is an example, a very typical example of a matplotlib object that it generates. And the really nice thing about it is that you can resize it. There are controls along the bottom here, so I can pick up these controls and I can manipulate all of the things of the graph. So I can just drag stuff around and make it the shape and size that I want. I'll reset that. You can zoom in on the data. So if we had a lot more data, which we haven't, you can zoom in on sections like this, and then you can move around on. Oops, if we go back, that takes us back to there. You can also then move around on the data. So if you've got lots of it, you can see how I can scroll through the data, because I had actually zoomed in a bit. I can reset it if I do it home. And I can, at any point, I can save a PNG of that image. So if I wanted to put this into a publication, it's really simple. It just saves as a PNG, and off you go. So you can see that we've got all of the labels that we put on there. We've got the values in millivolts down there. We've got this in seconds because we divided them by 1,000, which gives us in seconds. So there's a minute's capture of the values in there. But you can see how really, really easy that is to achieve. So we have our program. Don't forget to shut that down. So that's our entire program. Although a lot of this was just learning how. In fact, I can get rid of most of this at this point. Oops. Most of this I can get rid of for the purpose of printing our plot out. This was more about just showing you around the block with regards to pandas. What am I doing? What am I doing? What am I doing? Control. That's weird. That is weird. Let's supposed to be commenting that out, and it's not doing for some reason. That's strange. I don't even know how you do it from a right mouse click. That's odd. How do you do it? Toggle line comment. That's what I did. Control plus line. That's exactly what I was doing. How odd. I'll just comment all that out so you can see that the basic program is importing pandas. Okay, we're printing out the version. We import the file into the data frame. We say that we're interested in the X and Y, and we say we manipulate the data using pandas. We instigate the plot, we label it all up, and then we display it. So you can, that's the whole program is there on the screen. So if I run that, I can run that with the run button at the top to run the whole thing, and we should get syntax error. What we've done. What we've done wrong. Sorry. I'm just going to get into there. I can't see any, there's no syntax error in there. Let's try again. There we are. And there's our graph. So we've got 4 minutes left. So let me just have a, let me go and take you and show you a quick look at Dave's stuff so that we can identify, I can very quickly show you. Now, his is obviously a lot more to it. This is the whole project here. If you bring it into Visual Studio, the nice thing about that is that you can, if you bring it in using the Git functionality, and I won't show you how to do that, but if you bring it in, if you clone it from the Git repository, the nice thing is that you can go in here and you can do pull. And I'm not going to explain Git to you, but if I do pull in there, what it's going to do is pull the latest version. So whenever Dave makes any updates or modifications, you will get, by doing what I've just done there, you'll get completely the most up-to-date, latest and greatest stuff, which is great. In time, I'm sure that he's going to make it so that people can put their own work in and then upload that into the system, and we'll see how that goes. But if you want the latest from his project, that's a really nice way of doing it. I mean, it's very easy to manage. But if we look at his data, first of all, let's have a quick look at his data. You'll see that he's got this line at the bit of the first line, which is some sort of metadata. But then on his first line, before the data, he has the headers, which is exactly what we did. He's actually using comma delimiting on his, so that means there would be no where the sep equals that we had in our program, you would use a comma. But that's exactly the same technique as that he's used on his existing data or his original data. So all his files have that header on the top, so you can use exactly the same technique as we did. Now you are going to have to do a little bit of fancy footwork because you've got some values here that don't exist. Now pandas can get snooty about that, but you'll see in his code he deals with that, and it's very simple to do it. What he does is, if you see the get data, now here's his data frame, and it equals read CSV, so it's exactly the same as ours. And because he's used commas, the commas are a standard separator for a CSV file, so he hasn't had to do the separator command. He's obviously got his files stored in a variable somewhere. I don't know where. He passes it into the function as a parameter. So, but that's basically the file name that we had in there. He's skipping row 1 because row 1 had that metadata in it. So it's exactly the same as what we've just done. Now, what you'll notice here is that these values is creating 3 data frames, in fact. But these first 2 are the ones which have I don't know what these values actually are, but this not na basically means ignore empty values. That's what that is. So if you do have data with empty values in it, it seems that it's possible that this muon detector can generate empty data points. And if that's the case, then you have to use this dot not nar in order to ignore any. So if you're wondering what that is, that's what that does. But the bit that we've just done is pretty much the same. So he's got this computed time. So we had the elapsed time in milliseconds, but he's now got computed time. Now, what he's done is he's done some fancy footwork in the reading software where it takes the actual PC's timestamp and then uses the elapsed time values and then calculates actual real time values, and that's what the computed time is. So there's an active discussion on the groups about that if you want to get involved in that, because it's sort of there's obviously a lot of discussion to be had there before we arrive at something which is going to work and be accurate and useful in the future. But the values, essentially, it's the same as what we've just did. So he's created a data frame with 2 columns of data in it, which are there. And then when he comes to print them out, it's a fairly similar job. I'm not going to go to that because it's very, very similar to what we've just done, but he's got it in there's a plot section. But I'll just really basically show you that what he's doing is really similar to what we've been doing. Just a little bit more nuance in it, obviously, to cater for some of the more advanced bits and pieces. And then when you look at his plots, if I look, in fact, image.plot, he's actually plotting. This is the main plot is the one that like we did is pretty much the same piece of code as we did to get the grey elements in there. But then he's got this red stuff in here. Now this is what's called a subplot. So you can actually plot as many graphs as you like on one graph, or as many subplots as you like. So if you look in his code, you'll see that he's got this thing called a subplot, which means that it will overlay other data, and that then allows you, as you can see here, he's got two y-axes, one on the left and one on the right, one which is the same as ours, and this other one which is this window frequency in hertz, which is to do with the time this corrected time principle. So I don't quite know what this is showing really, but I'll leave that up to the astrophysicists to tell me later on. But you can see that these graphs, I mean, he's got 2 displayed on one picture there, and again, you can do that quite easily. But this is all exactly the same stuff as what we've been using. So that's how you get. We'll go back to what we were working on. So that's the nice, simple walk before you run version of what we need to do. So, any questions about where we're at the moment? We can save the data onto a file. We can take the file and we can make it into a graph. They're the 2 basic things that we wanted to achieve by the end of today. So I think we've maybe done that.
Any questions for Roo?
I've got one question, Roo, if I may.
Yeah, go on, Dave.
I struggled actually displaying the graph within Visual Studio, and I think I needed to be in interactive Python.
No, you just have to do plot show, and it'll do it.
Right.
Yeah, that's all.
Right. I ended up loading interactive Python and getting it up that way.
Yeah, well, that would work as well. But if you run it, I mean, this is just Windows, so I can just do Python. What did I call it? It's called simple. Sorry if I do SIM. Simple plot. Yeah. I'll just do that. There you go. Comes up.
Right. Okay.
But you do need to do the plot show.
Fine.
If you were in Jupyter notebooks or in interactive Python, which is Jupyter notebooks is based on interactive Python, then this is implicit in it. So it takes the output. You remember before I did that, if I take that out, it just prints out the object. You remember? Actually, oh, I forgot to save it. I always do that. Let's try saving it this time. So if I do that now, you'll just get the object. Actually, no, it didn't, because it didn't do no. But yeah. Anyway, that's what happens. Whereas in interactive Python and in Jupyter, that show thing, it knows what the game is, so it does it for you.
Yeah.
That's true. Yeah. Anyway, there you go. That's answered that question.
Super, thank you.
Yeah, go on.
I was just going to say any more questions. Well, I was just going to say that's got a mate in effect, which is plot.print.
Yes.
Or save plot.save.
Yeah, if you do plot.print, then it will print it to it does exactly the same as when we ran it, is hitting the save this save thing. So it basically allows you access to that. So and you can pass the name of the PNG. In fact, I think you can choose any format you like. So JPEGs, all of those. So you can choose what format you want, what the name is, and it'll save it to a file. So you can generate actual pictures directly from your code as well.
I think save fig is the method that you want.
Yeah. It's which one, sorry?
Save fig is the method for saving a figure to a file.
Right. Yeah, there's a whole bunch of.
There's probably a bunch of
there are quite a number of them, and it depends what environment you're in and all sorts of other things. But matplotlib is a fantastic library, and I mean, as I say, we really have just dipped our toe in the water here. I suggest that you go away and go and watch some YouTube videos. Someone like Corey Schaefer or one of those. I know I recommend him all the time, but he's very concise and to the point. He's got some good ones on pandas and on matplotlib. There are a lot of the pandas ones are more about dealing with data, which is like for instance, you get a lot of people showing you, they'll take municipal data from councils, and then they'll show you how to find out how many buses are on time on a Thursday in this area and that sort of thing. So when you're manipulating that type of data, there aren't so many on scientific stuff, or there are some, but you have to sort of hunt a bit more for them. And the sorts of things that we want to do with them, where we're trying to do mathematical operations on ranges of data. But I mean, I touched on it here on that line 24 there. I mean, that's very simple, but it shows you the power of it. You can take a whole column of data and do mathematical functions, and that makes everything much quicker and easier. But it's a case of just watching a few tutorials and reading the documentation and just iterating until you get what you want. Lots of examples on matplotlib as well. Matplotlib has got loads of examples on there, and most of them are relatively easy to understand. I mean, sometimes there's some heavy duty maths in there as well, which goes over my head a bit. But so that probably takes us on to I mean, there's time for more questions. Yeah, go on.
Yeah, quick question, Ruth. I tended to use NumPy rather than pandas. Is there any big advantage using pandas over NumPy?
Well, NumPy, pandas is built around NumPy. So
I mean, I've used pandas for some very specific needs that I had, which was
if you look under the hood of pandas, it's got NumPy at its core. So it's using the NumPy arrays are the basic the basic way in which the data frames are made up. So a lot of the math stuff, like that divided by range thing that we did, divided by 1,000, that's been done in NumPy. So yes, NumPy, you can use NumPy on its own. And in fact, Dave Hardwick is using NumPy to do some functions as well. So they're available as pure NumPy functions, but they are also available within pandas, and the two are basically partners with one another. But NumPy is another mathematical tool which works is a matrix maths tool, which is really what both of these are. Well, let's say matrix. I'm using that term in a sort of in a non-mathematician's way, but you know what I mean when I say that. It's a multi-dimensional maths tool. So yeah, and we might look at NumPy a bit more, because next week what we want to look at is a bit more on the presentation, which is the stuff we've been talking about here, about printing out and putting it into papers and how you can represent your code. So we're going to be doing probably a bit about Jupyter Notebook and that sort of thing. But then I thought we'll have to have a word with Dave about this, but then he might want to join in for another session, which is more about the actual analysis side. So how do we manipulate this data? How do we, what sorts of things are we trying to discover from within the data, and how are we going to go about that using the tools in Pandas and NumPy and all the rest of them? But that's yet to be written, that bit yet. But that would have been my hope. Yeah. And I think the very last part of the whole thing was something which Paul was very keen to do, was to make a way of representing this data on some sort of web portal and or mobile phone portal, so that other people can see data coming from these muon detectors very easily. So that's probably that'll be the sort of icing on the cake at the end of the session. I don't know how many sessions we're going to be yet. I mean, we're sort of doing it as we go along, but we've only got an hour at each one, so we can't cover a lot of ground. So
I think until you get fed up with us, Rube.
Well, that's why. Did you notice how I'm roping in Dave here? I don't know how he feels about it. But
I put a link to Corey Schaefer's YouTube channel.
Thank you.
You pointed me at him a very long time ago, and I found him absolutely brilliant for getting a complete novice going.
He's good because he talks very quickly, which I think is a good thing, because you don't want to listen to somebody for hours on end. And he's very concise, and he just gets to it straight in there, and he's very clear. I like him. As long as you can stick with his pace, he's fine.
Yeah, and then you can always stop the video and have a play.
Yeah,
which is nice.
Yeah.
And the code's all posted. There's a GitHub. You can get his code and play with it. And yeah, it just, as you say, it cracks along at a nice pace, but you can always stop it and play with it. And just to pick up on Callum's question, as a complete novice, there's something Excel-y about pandas. You can sort of conceive them in the same way without having to worry about the maths.
Yeah, there are actually even books which are like pandas for Excel experts or something. I've seen books written about how, if you're really good at Excel, how you can use pandas, because they're very, very like you say, there's definitely a relationship. You can pretty much do all the things that Excel does in your code, and quite often with very little code, like we've just seen. It's quite powerful.
And once you start delving, if you can imagine it, there is a way to do it.
Yeah, I find it much easier when you start manipulating the data, like we knocked three noughts off the values of our milliseconds along the bottom there. We're doing that in Excel sometimes can be a little bit, you can get yourself in a bit of a knot with some of those. And if you wanted to put like best fit lines in and things like that, there's some really powerful stuff in Pandas for doing those sorts of things. Yeah, there you go. Any other questions?
Yeah, Roo, I've just got a comment really.
Yeah.
Some of us on Friday were at a talk by Alex Andrews, who was reducing Meerkat data. He was just looking for he was looking at data that was a massive sky survey, but looking for anomalies, and he was reducing the data by using AI. And I guess at the end of the day, we're also looking for anomalies which we could then relate to something astrophysical. And are there AI libraries that can be used on this type of data to look for anomalies?
Yes.
Oh, yeah,
I mean, I've played with, I've done quite a bit of AI stuff myself, mostly image manipulation stuff. And yeah, I've mostly used I've done it on PCs and but a lot with the NVIDIA SBCs, the little Jetsons, and they have their own set of, NVIDIA have got their own set of libraries. There are lots of them. Google have got them. Obviously, they've all got them. Microsoft, Google, a lot. I've been using the NVIDIA ones, and they are basically slightly different to what you're talking about, because what I've the only experience I've had are basically models where you teach them. So you show them you show them lots of images of what you're interested in. So if it's somebody's face, I mean, I developed a thing for the charity that I work with for disabled people, and it was for a chap that had motor neurons disease. And the very latter stages of motor neuron disease, you can't do anything other than move your eyelids. You blink, that's all you can do. And so he needed a way of calling his carers when he needed them by blinking. So I did a thing on an NVIDIA Jetson using that. And so what you do is you have lots and lots and lots and lots of images with somebody looking in every direction. I had about 200 images of him with his eyes open and eyes closed and all the rest of it. And then you basically teach that to a model. And then from that, it knows what to look for. And then you can just feed a video signal in, and then it will automatically detect whether your eyes are open or closed or whatever you're doing. So it's done by teaching. So it's slightly different. When you're looking for anomalous stuff like that, I don't quite know how that technology works. I know much more about these trained systems. But it'd be interesting to look into. There's such a lot of material out there, and it seems to be mostly free, because these companies are desperate to get everybody using it, of course. But looking at data for anomalies quite often becomes an image thing, because you look in Matplotlib and you get all these really funky charts where you can put data in every direction, and you can have colors and 3 dimensions and all the rest of it. And quite often when you put data into that format, you'll suddenly notice visually, as a human, you'll say, oh, there's something going on there. Look, there's a sort of weird wave going through it. The colors are changing in a particular way. And in some ways, I've often thought that AI learning systems could be taught to see differences like that as well. So rather than using the data in its raw form to do that, using it in a more visual way as well. I don't know. Might be completely wrong there, but it's always
to be played with in the future, I feel.
I definitely think that things like like meteor detection from a spectrograph, AI would easily be able to do that. If you teach it, and in fact, I've been trying to get a catalogue together of meteorite hits on spectrograms, so that I can teach an AI model, and then we can feed spectrographic images to it and see how good it is at detecting them, rather than aircraft and satellites and such like, which is generally what happens.
Yeah.
But doing it actually visually, as an image rather than the data itself. But that might just be my naive approach. Maybe if I knew more about data, AI data manipulation, there might be better methods, and I'm sure there are actually. But it might be something that Dave Hardwick knows more about, because I know that he's been involved in science, the data science, for a long time.
Yeah. Thank you.
Okay. Any more questions?
No, we're good.
Okay. I think a happy audience. Ru, thank you so much. It is intensely appreciated.
It's no problem at all. I hope. I mean, this is only really a introduction. It's only really basic. I know I'm not going very deep, but they're only short sessions, and that's the intention. And hopefully, we're going at a pace which people can keep up with, and they don't feel that we're, you know, it's like the Ladybird Book of Python or anything. I think we're doing reasonably useful work with it. It's where I'm stuck with the muon thing is that I don't understand what we need to get from the data, and that's my next bit I've got to look into. So that's why I'm quite keen to talk to Dave about this stuff.
Yeah. Good. Okay. Well, in that case, then I'm going to press the record button.